let us begin Chapter 5, Sections 1 and 2. Problem number 1, evaluate each expression for the replacement values given. So here let's substitute x is equal to 2 and y is equal to negative 1 into our expression. Negative 4 times 2 squared times negative 1 squared. So here we have negative 4 times 4, negative 1 squared. We have negative 1 times a negative 1, which again, negative times a negative is a positive. So we have negative 16 times positive 1 is equal to negative 16. Second part of number 1, substituting y is equal to 5. We have 10 over 3 times 5 cubed, and 5 cubed is 5 times 5 times 5. 5 times 5 times 5, let's write it out here, 3 times 5, and this is 5 cubed. So 5 cubed times 3 is equal to 125. So 5 cubed is 125 times 3 is 375. So we have 10 divided by 375, and here we can simplify that. Simplifying 10 over 375 is equal to 2 over 75. And that is our answer for part 2, problem number 1. Problem number 2, use the product rule to simplify each expression. So here what the product rule tells us is when we multiply exponents, we add the degrees. So here we have negative 5 and 7 plus 6. So we add the degrees, so negative 5 to the 13th power. And we can just leave that as the answer, negative 5 to the 13th power. Following the same rule, we add the degrees, but here we can multiply the bases. So we have negative 2 times negative 2, which is positive 4. And we have z, 3 plus 2 is 5. Again, we multiply the bases, negative 2 times negative 2, and we add the degrees. 3 plus 2 is 5. The same goes to this next problem. We have negative 7 times 7. So negative 7 times 7 is negative 49. Now let's add a cubed and a 19. So again, we're multiplying exponents, so we add the degrees. 19 plus 3 is 22. So we have a to the 22 power. And b, we have b3 times b, which is b to the 4th power. And that is our answer. Using the quotient rule for number 3, again, the quotient rule tells us that we subtract the degrees. So we're subtracting the degrees here. We have negative 6, and 13 minus 11 is equal to 2. So negative 6 to the 2nd power is equal to negative 6 times negative 6, which is 36. The next problem from number 3, x to the 8th over x. Again, we subtract, so we have x, 8 minus 1. Again, when you don't have a degree, it's understood to be to the 1st power. And we have y, 6 minus 5. So 8 minus 1 is 7. So 8 to the 7th power, 6 minus 5 is 1. So we have x to the 7th y. Problem number 4. Here we have a formula. S equals 6x squared can be used to find the surface area S of a cube. Find the surface area of a cube with the side length of 5 meters. So here we have to substitute 5 into our x because our length is x. So we have S is equal to 6x squared, which is equal to 6 times 5 squared. So 6 times 5 squared, 5 squared is 25. 6 times 25 is equal to 150. And that is our surface area is 150 square meters. Number 5, find the degree of each of the following polynomials. So x plus 2 is a binomial because it has 2 terms. And the degree is 1 because that is the greatest degree of all the terms. So here your degree is equal to 1. And it is a binomial because you have 2 terms. The second part here, your degree is 2. That is the highest degree. And again, you have 2 terms, which means you have a binomial. So here you have a degree of 2. Let's go back here. Number 1 was the degree of 1. So you have a degree of 2, and again you have 2 terms, which means you have a binomial. Now the last part is you have 4 terms. So here you don't have 2, 3, 4 because you have 4 terms. Here you have no name for this polynomial. It's just a polynomial with 4 terms. And the degree here, you look at the highest degree, and the highest degree is 4. So the degree is 4, and you just have a polynomial with 4 terms. A polynomial with 4 terms. And that is it for number 5. Number 6, simplify each of the following by combining like terms. So here when you're combining like terms, you look at the degrees. If the degrees are the same, then you can combine them. So 12k cubed minus 9k cubed, the degrees are the same, so let's subtract. 12 minus 9 is 3, k cubed plus 11. And that is our answer. The next problem, you have the 2.5 squared. Here there's a y, it's supposed to be there, 2.5y squared. So let's combine the y squareds. We have 3.2 minus 2.5, again this is a y squared. And then the y, you just have 7.6 and negative 8. So plus 7.6 minus 8y. Now let's combine 3.2 minus 2.5 is 0.7y squared minus 0.4y. And that is our answer in simplest form. And for number 7, you want to add and subtract our polynomials. Again, you want to look at the same degrees. So here you want to add these 2 polynomials. 4x squared is in the second polynomial, but you don't have an x squared in the first polynomial, so we just keep it. We can't combine it. So we leave it as 4x squared. Now you have 3x minus 3x, which cancels. And then you're left with negative 8 plus 3. Negative 8 plus 3 is negative 5. And that is our answer, 4x squared minus 5. And the last one here, again, you have a negative. which means you have a subtraction. So the best thing to do is to distribute that negative. So we have 5x squared plus 4. Negative times a negative is a positive, 2y squared. And a negative times a positive is a negative 4. Now let us combine like terms. We have 5x squared. We don't have any other x squared terms. So we keep it. Same with the 2y squared. We don't have any 2y squareds, but the positive 4, negative 4 cancels, leaving us with our answer of 5x squared plus 2y squared. And that completes Chapter 5, Sections 1 and 2.